Welcome to EPG Pathashala. I am Ravi Korisetter, Senior Fellow, Dr. V.S. Wakankar, Archaeological Research Institute, Bhopal. In the subject of Indian culture and paper 2 on pre and protohistoric cultures of India, in this presentation, we will look at the geographical and climatological background of the Indian subcontinent, which has bearing on our understanding of the development of prehistoric cultures in India. Aims and objectives. The student of Indian prehistory is required to have background knowledge of India's environments and natural habitats to be able to understand the development of prehistoric cultures, which were largely shaped by natural processes. Therefore, in this presentation, the aims and objectives are 1. Geographical features of the Indian subcontinent, 2. Physiographic features, 3. Outline of geological formations, 4. Drainage network, 5. Monsoon circulation and natural habitats across the Indian subcontinent. The Indian subcontinent represents a large and continuous continental landmass lying between the Himalayas in the north and the Indian Ocean in the south. Modern India is equal to Europe without Russia. It has 15,200 kilometers of land frontier and 57,000 kilometers of sea frontier. Its area is 3,267,500 square kilometers. This is the 7th largest country in the world. India extends 3,200 kilometers in the north-south direction and 2,960 kilometers in east-west direction. The subcontinent includes modern Pakistan, Nepal, and Bhutan. This is considered a part of the Old World in view of the evidence of early Paleolithic settlements distributed across the Indian subcontinent, similar to the ones found in Africa and Europe. On the present showing of Paleolithic evidence of settlements, Sri Lanka had remained isolated during the early Paleolithic times and was colonized by modern humans around 50,000 years ago. Hence, it can be regarded as part of the New World like those of Australia and the Americas. This slide clearly presents the physiographic configuration of the Indian subcontinent. We have the great Himalayan arc in the north, and to the northwest of the subcontinent we have mountain ranges such as Sulaiman, Kirtar and Hindu Kush mountain, now bordering Pakistan, Iran and Afghanistan. As we move eastwards, we see another chain of mountains going north-south, separating India from Eastern Asia. This mountain range is known as Arakanyoma, or popularly as Burma Mountains. South of the Great Himalayan Arc, we have the sub-Himalayas, which are also known as Sivalik Hill Ranges. Sivalik Hill Ranges are found all along the foothill of the Himalayas in between Pakistan in the west and northeast India in the east. South of the sub-Himalayan region is the Great Indo-Gangetic Plain, formed by a network of streams. This Indo-Gangetic Plain is carved by the network of streams which have deposited alluvium transported from the Himalayan region into this geosyncline lying north of the Vindhyas and as well as south of the sub-Himalayas. Further south of the Indo-Gangetic Plain is the continental bulge, which is also known as the Deccan Plateau. Deccan Plateau extends from the Vindhyas in the north to the Nilgiris in the south. Further south of the Nilgiris, the Western Ghats continue, and eastwards of the Western Ghats, we have the Tamil Plains. Along the Western Ghats between the Kanyakumari in the south and Gujarat, eastern Gujarat in the north, we have the Great Continental Divide separating the coastal lands from mainland Deccan Plateau. Similarly, the Eastern Ghats, which are not as continuous as the Western Ghats, are found along the eastern frontiers of the peninsular South India. To the east of Eastern Ghats, we have the deltas of Godavari, Krishna, Kaveri, etc. The mainland Deccan Plateau is drained by a series of rivers which originate in the Western Ghats. Owing to the easterly slope of the Deccan Plateau, most of the rivers rising in the Western Ghats flow eastwards and ultimately drain into the Bay of Bengal. The physiographic configuration of the Indian subcontinent is characterized by the presence of the Tibetan Plateau in the north and the Indian Ocean in the south. And in between, we have the great continental landmass. This particular configuration has played an important role in the rise of monsoon circulation across the Indian landmass. Before we go into the geological and physiographic makeup of the Indian subcontinent, let us have a cursory idea of the geological timescale, which is based on the stratigraphic development of various types of rocks and fossils contained in these rocks. The oldest rocks date back to roughly around 4.5 billion years ago, and the geological formations beginning from 4.5 billion years ago to about 500 million years ago have been referred to as Precambrian rocks. This Precambrian period is divided into Prehistoric, Archean, and Protohistoric. These terms refer to presence or absence of primitive life forms in the form of fossils in the rocks, followed by Cambrian time period dating from about 500 million years ago. The major stratigraphic divisions include Paleozoic, Mesozoic, and Cenozoic. The term zoic refers to the presence of different varieties of life forms in the geological formations. Paleozoic refers to the oldest life forms, Mesozoic refers to middle life forms, and Cenozoic refers to recent life forms. The Paleozoic is subdivided into various periods such as Ordovician, Silurian, Devonian, Carboniferous, Permian, etc. Mesozoic is subdivided into Triassic, Jurassic, Cretaceous, and the Cenozoic lies at the boundary between Cretaceous and Tertiary, placed around 65 million years ago. Cenozoic is further subdivided into Tertiary and Quaternary. Tertiary is also further divided into Paleocene and Neogene. In the context of understanding prehistoric period, the Cenozoic period is of great relevance to our study. Paleogene has been subdivided into Paleocene, Eocene, Oligocene, and Neogene includes Miocene and Pliocene. End of Pliocene marks the beginning of the Quaternary period, and Quaternary period is further subdivided into Pleistocene and Holocene epochs. The evidence for the earliest human ancestors is now documented from geological formations belonging to later part of the Miocene and Pliocene, and during the Quaternary, early Quaternary, we see the full-fledged development of human ancestors who were also capable of making stone tools. Although our knowledge of the Quaternary period is more relevant to understanding cultural evolution, we are sure a background information of the geological and physiographic evolution of the landmass, that is the Indian subcontinent, equips us to obtain a general account of environment of the region, which definitely played a major role in the habitability of distinctive congenial environments that determined patterns of hominin expansion and gave rise to a clear pattern in the distribution of early settlements. This also helps in delineating the settlement patterns during distinctive cultural periods. During the last 50 million years, combined geological, tectonic, and geomorphic processes have given rise to the present physical expression of the subcontinent's landmass. Prior to this timeline, the Indian tectonic plate was separated from the rest of Asia by the Tethys Sea. The plate tectonics processes led to the collision of the Indian plate with the Asian around 50 million years ago. This collision was a critical landmark in the series of geological events that eventually led to the formation of the Indian subcontinent. The physiographic configuration of the subcontinent is the result of geological processes involving crustal evolution and plate tectonics. Crustal evolution refers to the formation of successive geological strata and the emergence of shield landscape. Plate tectonics refers to the movement of crustal landmass under the influence of rifting, drifting, and collision of these land masses. In the next couple of slides, we'll have some idea of the plates across the globe. This particular slide gives us an idea of 7 major tectonic plates which have come together They have a continental area as well as oceanic area. Sometimes the boundary between plates are on the continental areas and sometimes they are in the oceanic area. So these major plates, plates such as the Indian plate, the Arabian plate, the African plate, South American plate, and such other plates all have been fused together, and that has led to the formation of the continental sphere or the lithosphere, on which we have life on continental land masses as well as life in the oceanic area as well. We see the continental margins which are in the oceanic area are characterized by the presence of volcanic activity. Series of red dots that we see on this map give us an idea of active volcanoes, and that is why the continuity of red points on the map are referred to as ring of fire. In the continental areas, the continental plate boundaries are represented by the mountain formation, for example, the Himalayas, which have come into existence as a result of collision between the Indian plate and the larger Eurasian plate. This slide gives us a clear idea of the area covered by the Indian plate. Here one can easily recognize the presence of continental area as well as oceanic area. The red line demarcates the area covered by the Indian plate, and the various other tectonic features which are a result of collision and uplift. Across the Indian landmass, south of the Himalayan range, we have series of rift valleys, and the noteworthy rift valley is the Narmada rift that we see going east-west in central India. The Indian plate has come into existence as a result of fusion of series of cratons, about which we will gradually learn. The formation of the Indian shield is attributed to fusion of series of small Archean cratons by Proterozoic mobile belts under the mountain building activity, which are also referred to as orogenic cycles, during the time period from Paleo-Proterozoic and early Paleozoic. The Himalayas and the Indo-Ganga basins have come into existence as a result of northerly drift of the Indian plate from south of the equator and consequent collision with the larger Eurasian plate. This gradually led to the convergence of the Tethys Sea, which had separated Indian plate from the Eurasian plate. The geological history of the subcontinent begins from the time of Archean. This is followed by the formation of a series of rock strata found distributed across major basins that are known as Proterozoic or Purana basins. Some of these basins became part of the Himalayan mountain formation and are now part of the lesser Himalayas. The rest of these basins, spanning the time period from mid to late Proterozoic, are found scattered across peninsular India. Relatively younger rock formations belonging to the Phanerozoic era are found in the Gondwana basins, well known for their coal measures. Between the Aravalis in the northwest and Alikuli and Satyavedu hills in the southeast, they range in time from Permian to Cretaceous. This map gives us an idea of the series of cratons that have been fused together by the mobile belts such as Eastern Ghats mobile belt and Aravali Delhi mobile belt. Between these two mobile belts, we have cratons such as Bastar Craton, Dharwar Craton, Pandian mobile belt, Singhbum Craton, etc. Their coming together has given rise to the formation of what is known as the Indian Shield. The Deccan Trap region is also referred to as Deccan Volcanic Province. It is much younger than the basement complex represented by granulites, granites, and greenstone rock formations found across the peninsular region. Between the Deccan Tracts and the basement complex, we have the Purana basin rock formations and the Gondwana rock formations that have been documented in different parts of central and peninsular India. This map also gives us fairly clear picture of the area covered by distinctive geological provinces that have been identified based on mapping of geological formation and their distribution across the peninsular region. The most prominent rock geological provinces that we know in peninsular India are the Deccan Volcanic Province, which has come into existence since 65 million years ago, and the Kadapa formations in southeastern part of peninsular India, and the Dharwar Craton, which is represented by the oldest rock formations in the Indian subcontinent. In addition to that, similar provinces formed by Precambrian rocks are also distributed in the region south of the Indo-Ganga plains. The Deccan Volcanic Province is made up of continental flood basalt eruptions in the form of Deccan volcanics around 65 million years ago. The Indian peninsula preserves evidence of fusion of smaller cratons by the Proterozoic mobile belts. There are 4 cratons: Dharwar, Bastar, Singhbhum, and Bundelkhand, as shown in the previous slide. There are 4 mobile belts: the Eastern Ghats mobile belt, the Pandyan mobile belt, the Satpura mobile belt, and the Aravali Delhi mobile belt. These mobile belts were responsible for bringing the cratonic areas into a shield landscape. These crustal features constitute the peninsular shield and are composed of greenstone rocks and high-grade gneissic and granulitic rock formations. These basement formations are succeeded by the Purana rock series, Gondwana sediments, Rajmal volcanics dated to about 115 million years ago, Deccan volcanics dated to around 65 million years ago, Cretaceous marine incursions in the Narmada Kaveri deltas, Mesozoic Cenozoic successions in the western Rajasthan, Kutch and Saurashtra, and mid to late Quaternary alluvial sequences along the river basins in the peninsular region. The Gondwana sediments range in time from Permo-Carboniferous to Triassic, 290 to 280 million years ago, and mark the resumption of sedimentation in peninsula during the late Carboniferous times. The Indian shield in its central and western part witnessed voluminous volcanic province covers an area of 5 into 10 to the power square kilometers. The Deccan basalts are thickest 2000 meters towards the west and decreases to up to 200 meters towards the southeast and eastern margins. Here we have distinctive physiographic zones that were some of the areas where we have development of prehistoric cultures. In the northern Himalayan ranges, we have an intermountain basin which is known as Kashmir Basin or the Karava Basin. This particular basin lies between 2 mountain ranges, Janskar in the north and Pir Panjals in the south. In between these mountain ranges, we have the formation of the Kashmir Valley, where we have the Jhelum as a arterial stream along with a network of tributary streams. The Jhelum River is cutting through geological formations which have been referred to as Karevas. The Jhelum rises, flows through the Kashmir Valley, goes out of the Kashmir Valley and enters into the Potwar Plateau in modern Pakistan. A series of prehistoric sites have been documented from this area. Although we have no clear evidence of Paleolithic settlements in this region, we have Neolithic and later sites distributed across the valley. High altitude areas such as Ladakh and Trans-Himalayas, in recent years, archaeological surveys have also yielded evidence of human activity. South of the Himalayan range is represented by sub-Himalayas abutting the Indo-Ganga plain. As we move northwards, we have lesser Himalayas, central Himalayas, and then Trans-Himalayas. Trans-Himalayas are largely covered by the Tibetan plateau. And all these sections of the Himalayas are characterized by distinctive geological formations. So far, in this region, the distribution of Paleolithic and later archaeological cultures are sparsely distributed. As we move eastwards along the Himalayas, we have the region between the Himalayas and the Meghalaya plateau drained by the Brahmaputra river. The river Brahmaputra has its source in the Himalayas in Tibet. It is known as Sangpo in that region, and it drains down the mountainous region and flows southwestwards into the Assam Valley. And then to the south of the Brahmaputra plains, we have the abrupt landscape rising above the river plains, and this is known as Meghalaya Plateau. This region also happens to be the region which receives the highest rainfall during the southwest monsoon season. As a result, eastern India receives relatively higher rainfall and is covered by dense vegetation, and therefore this region is also referred to as eastern humid highlands. So south of the Indo-Ganga plain, as we enter the northern parts of the Vindhyan plateau, we have these tectonic features and the Narmada river flowing through a fracture in the hard rock formations. So it is also referred to as Narmada Rift, and further south of the Narmada Rift is the Satpura Basin, and both these rivers rise in the eastern highlands and flow southwestwards and ultimately drain into the Arabian Sea. Further south of the Satpura Basin, we enter into the peninsular river basins, beginning with the Narmada in the north and Kaveri in the south. So peninsular South India is drained by three major river basins such as Godavari, Krishna and Kaveri. This map gives us an idea of the extent of Deccan Volcanic Province. Major part of western India is covered by the volcanic rocks which are referred to as flood basalts that were erupted by submarine volcanoes which were active 65 million years ago. Major area covered by the basaltic area is now represented by modern Maharashtra and some eastern parts of Telangana and Andhra Pradesh. Further north in central India, basaltic outcrops are found in the Malwa region as well as Bundelkhand region also. In these areas, volcanic rocks are identified as basic volcanoes, and as one moves westwards into Saurashtra, series of volcanic lava rocks have been identified, and they are identified as acidic lava flows. In these areas, we have also adequate evidence of development of prehistoric cultures from the Paleolithic time onwards. This slide gives us a clear picture of physiographic landmarks in peninsular South India. The Western Ghats, the Eastern Ghats, and the Deccan Plateau, which has been divided into Northern Deccan and Southern Deccan. And the Deccan Plateau is characterized by a network of river systems which are also referred to as the Godavari Basin, Krishna Basin and Kaveri Basin. The most prominent orographic features are found along the Western Ghats and in the Nilgiri areas. The Western and Eastern Ghats converge at the Nilgiri mountains, and further south of the Nilgiri mountains we enter into the plains of Tamil Nadu. On the western coast, the river network a very short stretch, whereas on the eastern coast, the coastal landforms are also characterized by a network of deltas, the Godavari Delta, Krishna Delta and Kaveri Delta. Relatively, the eastern coast is much broader than the western coast. Western coast has been divided into Saurashtra coast, Konkan coast in Maharashtra, Goa coast in the Goa region, Canara coast along the Karnataka region, and Malabar coast along the Kerala region. The coastal areas in Tamil Nadu are referred to as Coromandel coast and the Andhra coast, Orissa coast and Bengal coast. This slide presents the network of streams originating in the Himalayas and in draining down the high gradient Himalayan and sub-Himalayan range, and as they approach the plains of the Indo-Ganga region, the rivers tend to braid across the landscape. As a result of this particular network of streams draining down from the Himalayas, and transportation of all disintegrated Himalayan material is deposited in this low-lying Indo-Ganga plains, and as a result of the erosional activity of this network of rivers, the vast alluvial plains of the Indo-Ganga region has been created. This slide further gives us a fairly close idea of the network of Ganga and its tributaries, which have given rise to the formation of the Ganga plains. And the network of rivers like Gandak, Ghagra, Gomti, Sarayu, Ganga, Yamuna, and such rivers are major rivers, and they are considered perennial rivers as a result of water being discharged into these rivers by melting of snow in the summer months, winter rains, as well as southwest monsoon. The rivers of the Ganga basin and the Brahmaputra both join in the Bengal region and have given rise to the formation of the delta. This is the largest delta anywhere in the world and is known for its dynamism because of periodicity and frequency of floods in the area that has both affected the stability of the settlements as well as the productivity of the landforms. So against this background, when we have to look at the distribution of archaeological sites, particularly the earliest settlements that we have documented, they are found to be more densely located in some of these geological provinces, which are called Purana and Gondwana basins. And these basins, which are shown here in a distinctive color, have given evidence of continuity of human settlements from the earliest times to most recent past. And this information about the distribution of settlements is also looked at against the background of the monsoon circulation that takes place over the Indian subcontinent. As we mentioned in the beginning, the Himalayas, the Tibetan plateau in the north, and mainland continental area is south, and further south we have the Indian Ocean. Thermal differentiation between the oceanic area, continental area, and the plateau area have caused the onset of monsoon circulation over this land. The southwest monsoon sets in during the summer months and traverses northeastwards into mainland in peninsular India and up to the foothills of the Himalayas. The distribution of this monsoon precipitation over this area is also governed by the internal physiography. The Western Ghats, the Himalayas also play a very important role in the way in which the variation in the precipitation across this landmass is governed. Southwest monsoon precipitation is highest along the west coast, followed by the Western Ghats region. And as we move away from Western Ghats region into the inland regions of Deccan Plateau, the rainfall precipitation decreases. As a result of decrease in the rainfall, we have the formation of deciduous forest ecosystems on the leeward side of the Western Ghats, and further inland we have rain shadow areas which have given rise to semi-arid ecosystems. And as we move further northwest of this particular region, the rainfall precipitation is much lower, and as a result the formation of the Great Indian Desert has also occurred. The monsoon is characterized by two major streams, one originating in Arabian Sea, another in the Bay of Bengal. The Bay of Bengal monsoon stream traverses much more faster into the mainland, and that is the reason why the Meghalaya plateau receives much higher rainfall than the proximal area of southwest monsoon. This unequal distribution of rainfall has given rise to formation of a diverse network of ecosystems characterized by vegetation cover and biodiversity. Whereas the density of population that we see in modern times from the beginning of Neolithic times, the distribution is found largely in the open savanna grassland areas. Dense forest areas have so far not yielded evidence for early human occupation. And marginal environments, the distribution of sites is also sparse. So the network of ecosystems that are a result of the rainfall variation across the landmass and the geological formations distributed across the peninsular India containing variety of rocks, minerals and metals have played an important role in the rise of early cultures, and that gradually gave rise to the formation of urban societies in the Indian subcontinent. For more details, I would like to recommend the e-text which has details about the various natural factors, natural environments, and natural other processes operating in the Indian subcontinent. Thank you.